In part 5 of my do-it-yourself air duct cleaning tools video series, we saw how effective a modified dryer vent brush kit could be for removing dirt, corrosion, and crud stuck onto the inside of some HVAC ductwork. The cable worked well as a DIY duct brush for the rusty old metal ducting, but it left scratches behind, which might make them harder to clean the next time, as well as possibly promote corrosion. The cable would also damage the flexible plastic ducting. Looks like I'm going to need softer brushes. So now in part 6, let's see how some less aggressive homemade duct brushes were made using some items I had lying around the garage. My reversible drill-powered dryer vent rotary brush kit will be needed again, for the flexible rods mainly. This brush guide I made during part 5 will also be needed for positioning the brushes from side to side in the rectangle duct. I simply bend the wire to adjust it. This flexible plastic ducting looks delicate and hard to clean. I think broom bristles or strings or small rope in the place of cables could possibly work. It's got that residue problem, and I want to use the stiffest brush possible without damaging the plastic. Maybe a simple plastic brush made from zip ties would be soft enough not to damage the flexible ducting, but still stiff enough to remove that residue. I select the wider of the two brands of 11-inch cable ties, and proceed to drill a 3/16 inch hole in the end of a piece of 1/2 inch by 0.35 aluminum round tubing. This was the best option I had on hand, although a slightly thicker wall would have fit onto the connectors tighter and better. The connections on the ends of the brushes and rods are basically just 1/2 inch steel tubing with an inside diameter of about 10.2 millimeters, while the part that fits into the tube is around 9.8 millimeters, for a clearance of almost 1/2 millimeter. The inside diameter of my aluminum tubing is nearly 10.8 millimeters, which is a difference of 1 millimeter. Quite a bit. Maybe too much. 4 more holes are drilled for the brush bristles to secure through. Then I install some zip ties. This tube doesn't need to be aluminum, but it's good that it's fairly lightweight, as we'll see in a bit. It's a universal hub that different brush bristles can attach to. Broom bristles, rope, cable, string, zip ties, etc. The ties are pulled through as far as they'll go and seem pretty secure. Centrifugal force will probably hold them in place. The end of the tube is a little rough and kind of sharp, so a little hot glue cap was put on the end. Polishing the leading end of this tube may have been a better choice. Time for a test. In vertical segments of ducting, it might work okay at this length, but in horizontal segments it has a problem. The ties are mostly coiling up due to their contact with the table. If this was the floor of some ductwork, I assume the issue would be the same. So I change over to a drill with a much higher top speed. At around 2000 RPM, it really lifts itself up. But I don't really want to spin the rods that fast while turning corners with them. The length of the ties coming from the tube was cut down to 7 inches, and that made a huge difference. Now the brush is able to lift itself off the table and fling the bristles out more consistently and evenly at only 1200 RPM. I believe the length is good. This configuration gives me about 1 foot of coverage side to side and about 9 inches top to bottom. 6-inch bristles may be better though. Let's see. I like how it feels. Rotates a lot smoother. Only about 1 inch or so of coverage was lost side to side. I'm going to stick with this length for now. This battery drill has a rated top speed of about 1300 RPM. That's about as fast as I want to go with these rods when unsupported. Here's one of the reasons why. Most of the rods are a little bent, and my homemade brushes are not well balanced. I assume these were contributing factors to why it got so out of balance. Definitely dangerous. It can work when the rods have support though, but higher speeds are still more dangerous. Interestingly enough, when a couple of rods or more are used together, the imbalance seems to be shared somewhat between them. and I can spin them fast with less support. Wonder what would happen if the ties were oriented in a different direction. I rotated the ties 90 degrees inside their holes and hot glued them in place. Let's try it out. Actually seems pretty good for only 350 RPM. And very stable. At 1300 RPM it lifts the center hub off the surface quite a bit. But not like it does when spinning at over 2000 RPM. The spinning rods handle bouncing better than I expected. Time to see if it can clean. The coverage isn't great at 1300 RPM. Accidentally bent one of those tabs up. Don't want that to happen. .350 RPM actually works with this configuration. The coverage is good. And I think it could probably sweep debris okay. Need to remember to keep it away from those tabs on the right hand side. I'm hesitant to use this powerful corded drill in the ductwork, but I've got to know what 3000 RPM can do. It's definitely cleaning. Good to see it working, although spinning the rods this fast still scares me. I need to be careful not to overheat the rods where they spin against the ductwork. A few cuts in the end of a tie gives it a more brush-like tip. I even bent them out in an effort to improve their coverage. Might work. May also soften the tips and make it less aggressive. If they don't clean well enough, then I'll just cut them off. Now I want to try making a brush from some 1/4 inch rope. This time the hub has 6 holes and a length of about 1 5/8 inches. If I want more bristles for my DIY brush, then I'll just cut a longer piece of tube and drill more holes. The sharp edges on the tube will damage the rope, so they need to be rounded over. Putting tape on the end of the rope helps to get it through the holes. After pulling enough rope through, I tie it in a knot around the hub to secure it. It'll work for testing, but I'll change it over to hot glue once I'm sure the rope will work as a brush. It's plastic rope, so the ends can be melted together with a lighter. Each of the ropes extends out from the hub around 12 inches, and a ring of hot glue is placed around 4 inches from their ends to prevent unwinding. Simply tying a knot there would work also. We have a problem. When spinning against a surface, the brush coils up almost completely under its own weight. Tying knots or adding more hot glue towards the ends of the ropes might help, but the rope is too big for my project anyway, so I start by cutting the ropes a little shorter. 9 inches is what we'll try next. Same problem. I cut them once again, this time down to 7 inches. Not much improvement. I need to add weight near the ends of the ropes so that the centrifugal force acting on them will be increased enough to levitate the hub of the brush a few inches above the surface at about 1300 RPM. Extra hot glue and a knot placed toward the end of each rope was my solution to the problem. Much better. Now it looks like a brush. Spins both directions okay. Oh wait, here we go again. Well, actually it came uncoiled all by itself and did so under its own weight, which I'm glad to see. In this configuration and at my battery drill's top speed, the ropes have enough centrifugal force acting on them to lift the central hub off the table about 4 inches. I'm convinced the rope could work now, so I center each of the 3 ropes in the hub and secure them with hot glue. The glue should help provide some strain relief to the ropes where they pass through the hub. Taking the knots out of the center lengthened the ropes, and now it's coiling up again. I also took out the knots towards the ends. More speed easily fixed the problem. Higher speed means more danger though. When I bounce the brush around, it bends the spinning rods out of alignment. If they get far enough out of alignment at these speeds, bad things will happen fast. but it's cool to see how gyroscopically stable the whole assembly is. Those rods bend a lot before self-correcting. I put some knots just above the hot glue. Now the ropes are about 6 inches long with the weights placed at around 5 inches, and it should work with the battery drill. Tying the knots allowed me to shorten the ropes without cutting, as well as add more weight to the tips. I'm going to keep the brush like this for now. I think it's another good candidate for cleaning the flexible duct under the house. I use this plastic rope, but other types might be better for this task. These knots can get hooked on protrusions like screws and tabs inside the ductwork. The rope can be twisted apart, forming a loop, and I'm sure it can get snagged that way also. The ropes can be unraveled to help fix that issue, but then the brush has to be spun pretty fast to keep the ropes from coiling up. At 1700 RPM, the rope is still coiling up in the corners of this duct. Can't handle it, I guess. Maybe more speed will help. 3000 RPM isn't even enough to fling the rope out to clean the ceiling of this rectangle duct. It's trying though. It does a good job of cleaning out the lower corners. Let's see if my brush guide made from wire can fix this problem. It actually does help quite a bit by keeping the brush out of the corner. Now it's cleaning like it should, but I'm spinning it faster than I want to. The extra weight of the guide requires more speed to lift the hub of the brush off the floor. About 2500 RPM was needed. The 1700 RPM drill couldn't spin it fast enough. Check out what happened when I reversed the drill. Whoops. One of the ropes caught on the guide and bent it badly. Glad I wasn't using the large drill when this happened. Twisted pretty good. Bent back into shape okay. The rope got snagged on a gap in this loop. Actually, it was one of the hot glue end weights that got stuck, but I'm pretty sure the rope would eventually get snagged there also, especially if it had a knot on the end. So I adjust it to close the gap and sand off the sharp edges. Now it doesn't get snagged. However, the individual fibers of the rope could still potentially get wedged in the tiny gap remaining. So a little hot glue was used to cover it up. That's much better. Let's see if it gets caught when I force it to spin in a spiral around the rod. Seems okay to me. I spun it in both directions, but wasn't able to get it to snag. I should probably spin the brushes up slowly from a stop when using this guide. The sloppy fit of this tube over the male connector will only get worse in time, but it demonstrated that it doesn't need to be an exact fit to work. Of course, more precise would be better. Let's try out some of these bristles from a broom and a rotary brush. I use a 1/16 inch bit to drill pilot holes in a spiral pattern, and then finish with a 3/16 inch bit before cutting the tube to its final length of 2 inches. The bristles of the broom pull out easily with pliers. They'll be inserted through the holes and hot glued into place. The ends will be run past each other in the tube, like so. To secure them, I just insert some bristles through one side and inject glue from the other. Then bristles are pushed into the glue from the other side. After the glue solidifies some, I move on to the next pair of bristles. I chose hot glue because it's fast, but many other types of glue could also work. Don't think I would use any glue that dries hard as a rock, as it might shatter from abuse. I like the spiral pattern much better than the offset pattern used with ropes because I think it provides a more even distribution of the bristles. Should have taken the same amount of bristles from both ends, but the broom will still work fine. The holes for the push pins are drilled more precisely this time, with no gap between the tube and the shoulder of the coupling. This tube here has the hole too close to the end, which produces the gap and a lot more free play. These bristles were long enough to make a brush with a diameter of just over 11 inches. Larger ones could have been used though. Human power alone is all that's needed to operate this brush. Doesn't seem to really have a minimum RPM, but it certainly has a maximum. Let's test it with a 1700 RPM drill. Looks great to me. Handles the bouncing with no problem. The rod wobbles some, but it's fine. I wonder if it'll do 3000 RPM. One way to find out. Applying torque to these rods can make them bend, so I need to be careful and spin them up as well as back down slowly and smoothly. My drill has a crappy trigger which makes that difficult. Even though the tube has less free play on the coupler than the previous, its extra length is causing its wobble to affect the drive shaft more by throwing it out of center. This wobble begins to overcome the gyroscopic stability of the rotating assembly at around 2000 RPM. The tube probably needs to be tighter fitting or cut shorter, more like the tube from the previously shown brush. But I'll just use it with the 1700 RPM drill. Probably faster than I should be going anyway. Before finishing with the cable brush, I tried out this broom bristle brush to see if it could clean some of the dust and dirt in this nasty segment. I turn off the duct vacuum during filming so you can see what the brushes sweep up into the air more easily, but it's turned on immediately afterward. Although the brush barely cleans the bottom any, it did manage to remove the residue of dust that was stuck onto the top and sides of the duct. I really like this brush. Even seems to work okay as a hand-operated brush. Think I would cut the tube longer and install more bristles for a hand brush though. See how the bristles evened out some during use? I wore a face mask for testing these tools on the bench, but I think safety glasses are probably enough for air duct cleaning. Using a chimney brush was a suggestion provided by a viewer. This plastic chimney brush was one of the first things I tried to use before making my own duct cleaning equipment. The bristles are too stiff and I couldn't get it to work. Maybe a different kind of chimney brush could be made to work. Before I crawl under the house again to attack this flexible ducting, I want to make sure to have all the equipment I need to finish the job, because it's difficult to access and there's yet another tool I want to make first. I'm pretty happy with what these rotary brushes can do. They're more effective than the duct whips from part 2 were for cleaning off crud. But I'm not finished with those air whips yet. A couple of viewers mentioned substituting silicone fuel line for the surgical rubber tubing. I think that's a great idea. The rubber tubing couldn't hold much pressure and would blow up like a balloon if overpressurized. Another viewer mentioned automotive type vacuum hose, which I think can also work well. I wasn't sure if brushes of some kind could be integrated with the whips. So a little experimenting was done, and as it turns out, they can be. I'm pretty confident that this air-powered brush is worth exploring. So in part 7, we'll take a closer look at this homemade duct cleaning tool. Thanks for watching.